Alright. Hello guys, welcome to my YouTube channel. Today we are here to solve Leetcode problem of the day, and today is 23rd November 2024. Let's start with the problem statement first, and further we will go how we will approach and how we will optimize the solution. So let's start with rotate start with the problem statement, and the problem statement is rotating the box. So what this title says, rotating the box, it seems like there will be some box and you will have to rotate something. So rotation, and here if you will read, rotation is 90 degree. The box is rotated 90 degree clockwise. Okay, in the clockwise you have to rotate it, causing the sum of the stone fall. So now this is the keyboard. Now 90 degree keyboard, and there will be the matrix, and there will be gravity. So you can see that you can think about that there will, after the rotation of 90 degree, there might be some stone falling down. So we have not read all the statement, we just read the title. This is the matrix, and you some will be stone and some obstacle, and there will be some empty and 90 degree, and gravity will work on this, and you have to return rotation. Now you will see the example. You can see that when we rotate this matrix by 90 degree, this stone will fall to this, and because this is already on the base, so it will not go further down. So you can see that here the configuration of the matrix will change from there was a single row and three column, and now the number of column converted into number of rows, and number of column converted into number of rows, and number of rows converted to number of column. So this is the rotation. This is the rotating the box means. So you can see now. Let's start with reading the full problem statement, and we will observe ourselves that how much we understand the problem without reading the whole bunch of statements that are given here. So you can see you're given m cross n matrix of the character box representing the side view of the box. Okay, each cell of the box in the following, there will be a stone. Has means a stone, star means on a stationary obstacle, and dot means there will be nothing in the box. The box is rotated 90 degree clockwise, causing some of the stone to fall due to gravity. As I have already told you that gravity will work on the stones, not on the. You have to note that gravity will not work on the stationary obstacle. So you can see until on obstacle, or you can see that uh, each stone fall down until the current stone will hit an obstacle, maybe another stone or bottom of the box. You can see that here in the second stone fall down to on a another another stone. So on another stone. So gravity does not work on the obstacle position. It means that obstacle is stationary, and the inertia of the box rotated does not affect the stone's horizontal position. Okay, it means that this is not something like there is one, you know, there is one stone here, and it doesn't mean that this stone might go to here. it only give in this vertical direction only, that this stone, because there is the obstacle, so when you will rotate, these two will remain in the same position, but this one, because you will rotate, so this stone will hit this obstacle and come to this obstacle in this empty position. So you can see here. So this is all about the problem, and it is guaranteed that the stone reset on an obstacle, another stone on the box. Yeah, this one is highlighted statement for these statement. So you have to return, you have given m cross n and you have to return n cross m matrix. N cross m matrix representing the box after the situation described above. Okay. So how we will approach this problem? Let's start with this example. This is pretty good example. So we will understand that how we will approach the problem and then code. Okay. So this is the rotation. This is the solution of the problem after the rotation. So what will change after the rotation? Let's see. Here is the, let's say, 0, 1, 2, 3, 4, and 5. 0, 1, 2. You also have to understand that how this will change in the new matrix. So whenever you will rotate, then these 0, 1, 2 will remain in the same way. The sequence will not change. First will 0 come with 0, okay, 0, then 1, and then 2, and then 3, then 4, 5. Even though the row have converted into the column and column have converted into the row, but the number, the sequence of the column get converted into the sequence of in the same sequence number of rows. But in the when the rows are converted into the column, these sequence are altering. So you can see that this 0 will goes to here, and this one will goes to here, and similarly 2 will goes to here. So but in the new position, what we need, rows will convert into the in the same way. I will say that 0 row have been converted, 0 column have been converted into 0 row, and 0 1 first, this second row converted into this second column converted to this second row, and similarly. But in this case it is so, if the number of rows is m and column is n, so this will be similar. If this represent the r, so this will be the r, this also with the r, we will not change anything. But in the case of column, what we will do, we will say that total number of, so these are the representation of this given. So rows will similar, and in the case of column of the new matrix, so m will be the number. So what we will do, m minus, let's say, an a variable c minus 1. So this will represent the first, second, and sorry. So you have to make it 0, 1, and 2, so that we can put the values in it. So till now I have explained that how the rotation configuration will change and how we will manage it. Now let's start that how we can solve the problem. So you can see that when the rotation will happen, you will have to fill this one first, and so we will start from last. We will start from last column. So in the first row, you can see what we will do. We will manage. Let's suppose I will make something like this. One, one, two. There is the six, three, four, five, six. Okay, this one and something like this. So this is the empty. We will make a left pointer and right pointer, and we will say that, and at the beginning this two pointer will point to this position. So because you can see that here is the empty, so we will keep the left pointer, and this right pointer will move to the next. This is the right pointer here. So because this is the obstacle, so none of the stone can fall down till here. So what we will do, we will just remove these two, and we left and right will point to this position, because there is nothing. So left will be here and right will goes to here. Right will goes to here and left will be here. Let me erase this. Okay, left will be here and right will be here. Because this is the obstacle, so we will have to update left and right both to the next position. So left and right will goes to here, and this will be, so let's suppose L and R. This left and right will point to here, because these are the stones. So you do not have to, because L and R are same. Whenever L and R will be same, we will, because we hit a stone, because L R and same, we cannot, this stone cannot fall down after the rotation. So we will keep it as it is, and we will append the variable to the next one, and LRR, and similar the stone will be there, because LRR in the same position. We will do nothing and move further. So this is the stones. Here will be a stone, here will be the obstacle, it will be empty, and it will be the, and obstacle, empty, obstacle, and empty. This will be the configuration. As I have discussed that how we will rotation. Rotation will make sure that you have get the stone in the correct position after the rotation. So we do not have to worry about it. And now let's start with this row. So you can see that left and right pointer will point to here, but sorry, left and right pointer will point to this location, but there is no any stone. So left will be here, left will be here, and right pointer will move to here, because again you can see that there is nothing. So right pointer will move to because right pointer hit the on obstacle. This one is the obstacle. So in this position we appear the left and right pointer to this location. To this location, L and R will be, sorry, because we hit the obstacle, we will move both the pointer L and R in the next position. Okay, and this is the stones. This is the stone. So because L and R in the same position, we do not have to do anything. We will move this pointer to the next one, and stone L and R in the same. Similar way, stones are there, because L are in the same position. We will do nothing. We will again append this one, and here is the stone and L are in the same position. So we do not have to swipe anything. So let's start now with the third row. So the solution of this will be, here it will be the obstacle, and here will be the empty, and here will be the empty. Okay. Now Let's start with the second, this row. And for this row, we will see, so left and right pointer at the beginning. Left and right pointer will be here. So ln re, because it is empty, so we will just append r from here, or I will point to here, because we hit on obstacle, sorry, on stone. But so we will append the stone where where the left pointer is located. So we will append the stone and we will put on empty here, and we will append this to the next pointer. So left will here and right will goes to here. We will append an empty, and right we move the r pointer to the next position. So this is now we again hit the stone. So we will exchange stone, and here it will be the empty, and we will point. And then let me show you that now left pointer will point to here and right pointer will point to here. Again we found a stone, so we will move that stone to this position, so it will become the stone and it will become the empty. So again these two pointer will move to the next position. So in this case you can see that this will now the stone. Okay, then left pointer will move to here and r pointer will. So again we hit a stone. Oh, oh, oh. Sorry, we hit an empty. So I messed up this row. I have to explain it again, because it now has. I am explaining that this row again. There was a mistake here. So as this stone will move to the next position, this stone will move to the this position, it will become empty. So it will become empty. So L will in this position and R will goes to this. Again we have the empty position, so we will do nothing. We will just move the R pointer to the next one. So in this case, this one is also empty. So this is the stone, and this is the stone, and here is the L pointer. So we will just move this stone to the next this position. So this stone will goes to here and it will become empty. Okay, and we will move this pointer to the L here, and R we will move to the this position. So now let's write it correctly. This will be the empty. So now here it is a stone. We will move this stone to the position of the left pointer. So we will change this to this one. It will become a stone and it will become empty. So now original. So it will become empty and it will become stone. So we'll move the pointer to the left till here and right will goes to here. Again we will hit a stone. So we will move this stone to this position. So now it will become empty and this will become stone. So the configuration now, all the four stone will align at the bottom, and these two boxes, I mean these two cell will be remain empty. So after the rotation, now your task, we have configured all the stones on the basis of the rotation and the gravity that will work on each stone. So you just have to rotate, as I have explained at the beginning that how the rotation will work. that the sequence of column will get converted into the similar sequence of rows, but the rows get converted in the opposite manner. So the zero will goes to in the last index, and one will this one, and the last index will become the first index. I mean, first index of the column of the new. So you have to take care about it, and you just have to do the shifting in this manner by using the two pointer. So this is all about how we will approach the solution, and let's start. And what will be the time complexity of this approach, because we are iterating only once to each cell. So the time complexity will be order of, because we can do twice. So 2 into m into n, this will be the time complexity. So overall time complexity will be m into n. This is the time complexity, and we will take order of m into n space, because we need to make the new on the basis of, we have to make n into m. At the beginning we have m into n. So to convert this, you have to make another matrix whose rows and column will be opposite to this one. So the space complexity will be order of m into n, and time complexity will also be order of m into n. And let's start with coding now. So let's number of rows will be dot number of column, number of column will be 0. Okay, and for new box, but we will do character of, let's say box 2 will be new of size n into n. These are the m into n, and I have created n into n. So and now, as I have explained, that let's write this code first, that how we will rotate this and how we will store them. So for and row equal to 0, column row less than m, column row plus column equal 0 less than m. So what will be there, that the box 2 of column and row, because these are the row and these are the column. It is this loop is work with the to support the old matrix. So the box R and C, sorry, row and column, and these row and column will rows, and their rows will get converted into the their rows get converted into the column, but in the opposite manner. So what you will have to do, you will have to, this is the row, okay, m minus is it correct? No, it's not correct. This will, because the column, let's see here, there's the column is column number have the same sequence, only the row. So C will remain as same and R will become M and minus 1 because the rows are getting converted in the opposite manner. So that's why I have written M minus R minus 1. So how this is we will store and we will return it box 2. Okay, this is not int, this one is the char. Okay, now let's start coding the main algorithm that how we will work. So for int equal 0. Okay, so we will have to make two pointer. Let's say L equal n minus 1 and R equal n minus 1. And now while R is greater than or equal to 0. Okay, now if let's say that there is a stone there, so in the box of row and so this is you'll have to left and you have to say right. So if right, if first row and the column is right is equal to star. So suppose that first one is the star. If this one, if this one is the star, means this is the obstacle. So in the case of obstacle, we have discussed that we will, because right pointer will in each step, in each iteration, right pointer will move toward 0 in this way. So at the end I will just write minus minus 2. So we just have to move the left one. So left will become right minus 1. Because when we were, let's say that this is obstacle, so this obstacle we cannot exchange with any stone, so we will, both the pointer must go to the next index. So these the right and left will move to here. So that's why left will right minus 1 and right will at the end right will itself get appended. So this is now if I'll say L equal R. No, if let's say box of left, box of sorry, row left equal box of R. So if these sorry, if these are equal to hash, that means that it is a stone. So to exchange stone, we will have to exchange. So box of. So there is one more condition that if that L equal R. So in this case, you just have to move the left pointer, left equal to right, left equal to right minus 1, or you can just say that left minus 1 is okay, and this is not R, left equal to right. And if it is not there, so in this case, what we will have to do that box of R and left we can has and box of R comma right will assign an empty. So dot will start will represent an empty space. So this is the way, and you because you will have to decrease the left pointer, so we will decrease it here. So is there any, if there is, if it is there dot, and if it is there star, and if it there has and else, there will be the empty. So in the case of empty, we will just have to, no, else, in the else case, that there will be the empty if space. So in the case of empty space, you just have to move the right pointer only. So there, we do not have to move the left pointer, so that's why we are not moving the left pointer, we are just moving the right pointer here. So let's say that I think it's done. What happened? So you can see that star uh, has star, our output is has star symbol. There's nothing changed. Why is that? What will happen? Let's see. Mm, let's see that what happened. Mm, so it's not going down. Let's take it that if left and right. If there's the star, so in the case of star, we will just move the pointer to the left, and if there is the has, so in the case here is the right, I guess. Yes. If there is the right pointer, if there is the has, so in case of has, we will see that either both the pointer are pointing to the same index. So in this case, we will move the left pointer as well as the right pointer, and else we will just move the stones to the position where the left is pointing, and now we will decrease the left and we will assign to that cell with an empty space. So this is how this, now you can see that these available test cases have been passed. Now let's try to submit it now. So our code have been accepted, and let's see. Mm, our code have beat 68.29% of the people who have submitted in Java, and it's taken just only 8 milliseconds. And in case of memory constraint, it has taken 79.84 MB and beats 18.10% of the people. Let's see the time complexity here. You can see the time complexity is m into n, as we have discussed earlier. In case of space complexity, it is also m into n. So this is all about the problem. So if you have any query or suggestion, you can ping me below in the comment box. And stay healthy and keep growing. And if you like my videos, and it is helpful for you to grow, you can share with your friends. Please make sure to like my videos, and please share to your friends who are interested in coding as well as CP and DSA, please also subscribe my channel. Thank you.